All right, so in our exponentials unit, we're going to take a look at comparing an exponential table to a linear table. So we've kind of done this a little bit towards the beginning of the year when we were looking at linear versus non-linear, but we'll be a little bit more specific. So just as a reminder, we know linear functions have graphs that are straight lines. And from the beginning of the year, we know what an exponential graph looks like. It's something that's going to increase really, really fast, or we could have an exponential decay where it's going to decrease really fast, okay? So the general equation for a linear function, as we know, is y equals mx plus b. ROC just stands for your rate of change, and we know that the rate of change is constant in a linear function. So the graphs are always going to be a straight line. And our tables, because when we look at a table, we know our numbers are either going to increase or decrease, okay, consistently. Okay. All right, exponentials. This is what we talked about last week. So the general equation we now know is y equals a times b raised to the x. Remember, a is that's your initial value, and b is what your factor is, either whether it's growth or decay. So the rate of change of these, if you look at your graphs, definitely not straight lines. So my rate of change is going to be not constant because it's not going up or down by the same number. So these graphs are going to have curves to them, or what we considered non-linear, but we can actually give it that function name. We can actually call it an exponential. Now, the table for these, we're going to be looking for numbers that either increase or decrease rapidly. And what I kind of tell my guys is if there is an extreme change in the numbers. So think of EX in extreme as the EX in exponential. So easy stuff today. What we're going to do is we're going to take that information and we're going to apply it to the table. So the directions are to determine if each table is linear or exponential. Okay, if it's exponential, then we're also going to state whether it's growing or decaying. So remember, if it's growing, my number should be going up. And if it's decaying, my number should be going down. Okay, so what I'm going to do is I'm going to look at my x values and I'm going to say, okay, what is the difference between each one of these? So how would I go from a -3 to a -2? Well, I know I'd have to add 1. Same thing from going from a -2 to a -1. I'd have to add 1. And if I keep looking, these happen to be consistent. So my x values are good. Now let's take a look at my range or my y values. So how would I go from 14 to 10? Well, that means I must have gone down 4. 10 to 6, went down 4. 6 to 2, went down 4. And always double check, because not all the time are they going to be the same. So this one also, my range is also consistent. So that means this represents a linear function. And more specifically, because my rate of change is constant. All right, so let's take a look at the next one. Take a look at your x values and tell me what that change is. Well, this one happens to be very similar to the last one we did. So my x values are good, so that works. Now we have to take a look at our y values. Now remember, when we're doing these, we're either adding or subtracting. So then you got to ask yourself, how am I going to go from, how do I go from 4 to 8? Well, it means you'd have to add 4. Same thing from 8 to 16. I must have had to add 8. So this one, 16 to 32, means if I add 16 to 16, that gets me 32. This has a difference of 32. Now, if you're wondering how I'm getting these numbers, what you could do is take your higher number, take the second number and subtract the first number, and that'll get you your difference. Now, this one, if I look at my numbers, are these numbers consistent? Are they the exact same thing? No. So I'm actually going to put an X here. Now, if I also look at my numbers, is there an extreme change, say from 4 to 256? I would say that's an extreme change. So this is representing an exponential function. Okay. Now, more specifically, is I want to know, is it growth, is it growing, or is it decaying? So if you look at your numbers, if you look at your y values, I'm definitely going up. They get bigger and bigger each time. So this represents exponential growth. And this is because my rate of change is not constant. And again, there's an extreme change in the numbers. Why don't you pause the video and give the last two a try, and then go ahead and play and see how you did. So this one happens to be going up by the same amount. Now this one, adding 3. -1 to 2 is also 3. So because they're both consistent, this one is linear. And it's because the rate of change is constant. All right, -4, so this one going up by ones. Now this one, gonna be a little bit going down by 16. This one happens to go down by 8. You always go from the top to the next one. Down by 4, down by 2. Now 1 to -1.5 means I'm half. And then this one, okay. So again, this one was good. However, this one, I'll put a big red X. So again, if I look at my numbers, those are not consistent. So this one happens to be an exponential. Now more specifically, because my numbers are going down, if you look here, I started positive, went to negative, so this would be exponential. Oops. Decay. Because the rate of change is not constant. Any questions, feel free to email me. Make sure you complete the classwork on the quizzes.